We have Wilson Bonner and Alphys Chitwa, and they're going to do a reinterpretation of lithostratigraphic and structural configuration of the supersalt geology in the Konkola-Mingomba area.
All right, thanks, Tim. Thanks, Mike. Alpha and I are going to speak about some work that's very recent, very ongoing, and wanted to present here to show you what we found because we think it's pretty interesting and exciting, and then get your ideas and your feedback. Maybe not during the questions because I know we're not going to try to do those, but throughout the next couple of days while we're all here together. We will be talking about Mingomba, and I think a couple of talks are as well, but I'll start by just showing the location of where this, the data from this talk is coming from relative to the rest of the copper belt. We're in Kitwe in the middle of the diagram down there, and Mingomba is up at the top end of the Zambian copper belt, close to the border with the DRC. I want to start with a refresher of the regional stratigraphy of the Katangan Basin. Most of you know this from school, but the three units that we're going to be focusing on here this morning are those ones above the green unit there, which is, in our terminology at Mingomba, we call it the upper Umbrecha, but it essentially represents the former position of the thick accumulation of evaporites. And so the Mwasha Nguba Kundalungu section is what we will be referring to just simply today through the discussion as the upper stratigraphy. And that breccia, or that green unit, which separates the upper from the lower stratigraphy, becomes an important thing to remember during this talk. So we're going to be talking mostly about the stuff above that. Just back in time, those rocks of the Mwasha Nguba and Kundalungu were deposited, like I said, after that accumulation of salt, which represents, or which we see today as a breccia layer in most deposits, including Mingomba. And they are deposited during a time in which that salt begins to drive up into salt walls, diapirs, other things. That's what the local halokinesis diagram or box means during the which overlaps in time with the deposition of these sediments, and they end at the timing of the Lufilian deformation or the Lufilian orogeny, which is what Mike just wrapped up his talk talking about in the gray box, which falls around the start of the Cambrian. To put it onto a map, so this is back to the Mingomba area, that those rocks of the Mwasha Nguba and Kundalungu were mapped in this area based on the regional geophysics, so this is the magnetics underneath it, as a series of these circles, or these, which in circles in 2D in the geologic maps, but in the 3D models, they were thought to represent these synformal or synclines or basins, where the youngest parts of those circles or of those synforms were the middle parts of the synforms were the youngest parts of the stratigraphy. So the surrounding green is the Mwasha, and then as you go up in the strat column, so younger ones in Guba would represent the middle part of those synforms, which was a way of, the way we mapped them was the way we thought of them, which is that they represented these mini basins, or these smaller compartments of sediment that were caught up between two walls of salt or diapirs. And then on the diagram below, it just shows as they're squished together during the Lufilian orogeny and eroded, they're seen in their current configuration on that map like this. So the key takeaway from all that is that in that model, the youngest parts of the middle parts of the synforms would be the youngest parts of our stratigraphy. Let me just define some areas real quick as we look at some drill holes. So the Mingomba deposit sits within what's called the Lubengala synform. Next to it is the Kuiri South synform. To the north is the Kuiri North. And then I'll also show a hole or two from the Ilungu Basin on our Konkola West license to the south. But Mingomba is underneath the Lubengala area. In the Lubengala area, there was a logging classification for the Mwasha unit in particular that we adopted when we took over drilling in the area, which was defined as a series of like lithologies as you make your way up the drill holes to the key unit which marks that Nguba Mwasha contact, which is the grand conglomerate diamictite, which was recognized in some holes further to the north of the deposit. And that was the key evidence that bracketed everything below it as being the Mwasha and everything above it as the Nguba. So with that in mind, the Mwasha was defined as first this complex that I've talked about, this upper Rhone breccia that I talked about, which is thought to represent the former position of the salt or the evaporites. Above it was a thick accumulation of dolomitic siltstones, which were sometimes quite magnetic. And in the middle of it was this pink dolostone marker, PDS, or pink dolostone, which I'm showing in the middle cartoon, or the middle core photo. And this is something that was found in every drill hole in the area if it was drilled above it. And we had informally defined it as the pink dolostone. The Mwasha 3 unit was this very distinct and recognizable flooding surface, or black shale, which was present above the pink dolostone. And above that was a series of evaporitic rocks, including a very diagnostic marker bed sequence on the right there of really bright carbonate beds and really dark, finer beds that were interbedded on the order of, 5 or so meters, or 5 or 10 meters. And then at the top of the sequence was, again, some more evaporitic rocks, and then a thick carbonate that was pinkish or reddish, and before we got to the grand conglomerate diamictite, which I've shown a couple of pictures of, which was not always present, but it was present in the holes to the north. So it was with that model in mind of this Mwasha that we had 100 holes in, that we had recognized a number of marker bed units within it. The grand conglomerate was our marker between the things that were younger above it and older below it. It was that in mind that took us to explore in the Kwiri South Basin and then in the Olungu Basin areas, so areas around the Mingomba license. And as we went into those areas, the existing models and maps had varied a little bit in what was predicted in the middle of these synforms, or the synclines. But for the most part, it was either thought to be Mwasha or Nguba. And I'm going to show the results from that series of holes right there on the next slide. So 233, 240, and 253 as we head from the north to the south. And when we drilled them, we were surprised after a while that at least the holes to the north had collared in the Kundalungu. And we were pretty sure we knew this because we drilled a thick package of what looked like the petite conglomerate. And we kept drilling on this hole and eventually found the second diamictite. So we had all of a sudden 2 diamictites to constrain our stratigraphy, and it gave us the confidence to say that everything above that was Kundalungu, which had not been mapped or predicted to be in this area, and then the Nguba in between, followed by the Mwasha. And that was all fine, and it was very continuous across those holes, although they were collaring lower and lower in the sequence as we headed to the south. But when we, and another thing we did is at the same time we were drilling at Konkola West, so that drill hole in the Olungu Basin to the southwest, and our colleague Pamela had been drilling or logging both of these holes and had recognized across the upper stratigraphy, so this is all just above the breccia, 10 or so marker beds that were identifiable in all 5 of those holes. The problem was that we were having a lot of trouble finding them in the Mingomba holes. And this was, we were surprised why that would be. And it was even more shocking because a lot of the things that we had seen in the Mwasha where we logged them outside of the Mingomba area or outside of the Lubengala syncline appeared actually in areas that we described as the Nguba elsewhere. And then one day, in kind of a crazy afternoon, we decided to experiment. And what if we looked for those same marker beds in Mingomba, but didn't allow ourselves the constraint that they had to be younging upwards? And when we did that, pivoting on the grand conglomerate, because we were pretty sure that was correct, this fell in line perfectly, which is that all the marker beds that we had seen in the Mwasha, in Konkola West and Mingomba East, were present at Mingomba, just upside down. And that was a surprising result, and it was something we wanted to test with additional data. So once we did that just based on core photos, Our hypothesis was that the upper stratigraphy at Mingomba, or the Lubengula syncline, above the breccia was upside down. And we wanted to see first if we could see any paleo up indicators, and we narrowed in on this that identifiable marker sequence of dark and light bedded units that I mentioned in what was earlier known as the Mwasha. And we discovered that on the right, which are examples from the Kwiri South and the Ilungu Basin, that we could see that light bedded material was grading upwards, so downhole is down in both of these images, and it was grading into the finer sediments upward. And we saw the same thing in Mingomba, or the Lubengula area, except it was grading down. And you could even see some of the white clasts of that light carbonate material being plucked off into the overlying sediments, if you interpret that, as I do, as being structurally reversed. So that was another small piece of evidence that was very compelling to some of us, that we were looking at the Lubengula area, or the Mingomba area, that was upside down relative to the other holes that we were logging. We also looked at the magnetic susceptibility measurements. So this on our drill holes, we take a MAXS measurement every meter, and not wanting to wait 9 months for to cut the holes and have that geochemistry come back, we started with this. And again, this is looking only at the breccia and above, and we cut these holes at that level, and then rotated the Lubengula, or the Mingomba area, upside down, and found that the magnetic marker units, which is the red column, I should mention, the blue is natural gamma, but in the red data, which is the magnetic susceptibility, those peaks and valleys lined up much better when we rotated the Mingomba holes above the breccia upside down. And just to illustrate that, I've shown what our eyes were honing in on. And just to prove that you can do it not just with one hole, I'm going to show you again with another hole from the Lubengula or Mingomba area. Right, so it was around that time that Alpha was logging KN247, which he'll describe here as one of the furthest holes in the north of the Mingomba license, and he was seeing some things in his holes that might begin to explain some of these early strange observations we were making.
Thanks, Wilson. So at the same time, as Wilson has said, after we looked through the core and the natural gamma and the MAXS, there were a lot of hypotheses. The general one was Mingomba was upside down. As we were drilling in the upper stratigraphy of 247, David Selly and myself had this hypothesis of what we would drill through. So try to orient everyone. It's a bit hard. But the red there is the ore shell. I guess I can walk over here. The red is the ore shell. The yellow, I think it's yellow, is the contact between the shell with grit and the Quito section below. The blue is the contact between the shell with grit and the bank of Tolostone. And the black is where we predicted that we would see the upper and breccia, which is the former salt position. So there was no significant structural complexity that we predicted, and everything seems happy, just a general synform. But after we drilled down through all the markers that Wilson showed you in KN247, we discovered that this hypothesis was in fact wrong. And there was so much going on in 247 that prompted us to get more structural measurements in KN238, KN230, and all the holes down to the southwest, 217, 220, and everything. So that's the section. The section was done along the profile of the general Lubengula synform. So there's, again, to orient everyone, ignore the white space, it will be important later. We have the basement as the black line, the ore shell in red. That would be the Kitu section. The light blue is the shell with grit. This is the Bancroft Dolostone, and that is the the upper Rand breccia. So we went through. We did not see the diamictite, but structural data suggested that it would have been here. Although we didn't drill through it, we drilled through it in 238, 230, 233 here, and 217 there. We drilled through the dark siltstone that Wilson just showed, the pink dolostone. Went all the way down until we got to this point where we saw a very small breccia at 1930. There was a complete change of fasces. The fasces that you see, the lithofasces you see above that point and below are very different. So above, it's all just boring dolomitic siltstones. Below that, you see silty dolostones and clean dolostones. And also, there's a very apparent structural break. If you would notice, the bedding above seems to generally trend to the northeast, but right after that, to trend to the southwest, right after that, everything else changes and kind of trends the other way. So that was a really weird one. Actually, when we drilled through it, we thought that might have been the position of the breccia, but we drilled down and we got to the breccia around here. So that then was a really weird one. But after looking at the fasces and the change in structure, we interpreted that then as a ramp. So you can clearly see it's a really, really funny and thin one, but you clearly see there's a complete change in the fasces and in the structures after that. So we interpreted that as a ramp. And when you look above the ground, there's really something going on there with the structures, right? We see the bedding construction there suggesting that there's a recumbent fault with a nose right in KN 230. So if we zoom in there to the suprabreccia level of KN 238, this is at a 150 mark meters mark from the grand conglomerate below. So you see that from the construction there, it seems the bedding suggests that there's a recumbent fault and there's repetition of strata in the hole. And we went back to the drill hole and looked through, and there was indeed a repetition of stratigraphy that we saw across the axial plane. So the axial plane was gently trending to the northwest. All right, so from the grand conglomerate there, when you go up, you drew through a few meters of turbiditic fasces, just in between there, just some dolomitic siltstones before you get to this dark shell. You drew through some more dolomitic siltstones before you get to what we call the stripy marker. So it's a siltstone and dolostone beds just repeating. And then above that, you have a fluviofasces, so that's a sandstone that is cross-bedded. And above that, you have this turbiditic conglomerate, which, interesting enough, is fining downwards. So that means this limb is upside down, right? You go through that mark, the 150 mark, you go straight back into the turbiditic conglomerate, in this case fining up, before you get to the sandstone cross-bedded and into the stripy marker again. So this is another strong piece of evidence that shows that there's actually a recumbent folding that is separate from the general Lubengele seam form. What that means, if we do accept this hypothesis that the Lubengele geology is upside down, we then see that whatever we were logging as the general Mwasha before now becomes Kundelungu and Nguba. And then the Nguba can further be split up into the Monwezi, the Katete, and the Kakontwe using the markers that we were using before, that we were just calling as Mwasha 2, Mwasha 3, and whatnot. The pink dolostone that Wilson showed would then be the Kauke rose. Okay, and then above that, naturally, you should have a petit conglomerate, which we do see. We do see a unit above what we are now calling the Kauk rose that is very poor classed, is very class poor, but you can really see that it resembles, it is a diamictite, and you do see it in most of the drill holes, not just 230. So this is a snip of KN 230. So what that means now for the general cross-section across the profile is as we drew from the top in KN 238 in the core of the seam form, we only have Mwasha in the core, and below, just below the ramp that we saw in KN 247. And as we drew from the top, we go from Mwasha through the Kakontwe, the Katete, the Monwezi, and the Kundelungu before we get to the other Mwasha that we see in the ramp, but we don't see that in the other holes. So this is very interesting, and I think at this time the soils had started coming in, and we were doing some work on the geochemistry for the soils, and this was a chance for us to use the soil geochemistry to see if we can prove this hypothesis, so give more information to it.
Yes, so we wanted to test this with the regional soils data that was coming in around the same time. And I'm just showing the clusters. I'm not going to show the results. But this is, I think, 11 or 12 clusters built off most of the elements that we got results back from. And I've shown it over top of the magnetics. And I want to point out that in the area that we were drilling that had both of the diamictites, and we were pretty sure was right side up given the similarity to the Ilungu Basin and the paleo up markers that we were able to find. As we go from the basement, which I'm sorry I didn't indicate, but is just south of the license, or clips some of the parts, the southern part of the license, towards the inside of the, or towards the inner part of the syncline, we go from gray or yellow clusters through blue and green and then into light brown. And in the Lubengele syncline, we see the same sequence just in the reverse pattern, going from the middle of the syncline out. So in other words, younging in this direction and younging in this direction. And it seemed like a very good match with the observations that Alpha was making in the drilling at 247 and with the observations that others of the team were making in the drilling outside of the Lubengele or Mingomba area. So this is just a comparison of the maps before and after. Perhaps we would draw it. For the Lubengele syncline, originally it was thought that the youngest part the middle part of the synform would be the youngest part of the stratigraphy, and it was constrained by the presence of the grand conglomerate diamictite. We now think, with more regional context, that it's a synformal anticline, meaning that it's in a synformal geometry, but it is actually an anticline, and that the oldest rock is in the middle of the circle, if you will, and younging outward instead of younging inward. And everything around it would just be the breccias that would be represented by the lower Rhone. Now, how this happens is a mystery to many of us, and we've been racking our brains trying to figure out how you flip this and not flip the other parts of the license. So I'm going to just walk through two possible mechanisms for this, but I look forward to hearing from some other experts in salt and structural geology that other creative ways in which we might be able to pull this off. But one way to maybe perhaps do it is a early period of extension caused by an extensional ramp. um, uh, um, uh, potentially due to salt withdrawal being inverted during the Lufillian, and a drag fold being developed as that extensional ramp is squeezed back into place. And then I've just drawn a little dashed line to show the erosional level today, where that might explain why we've got upside down stratigraphy in Kundalungu on top of Upper Rhone. Another way perhaps of doing it, which is a bit more convoluted, I admit, but is at least something different, is a mega flap. So for those of you who don't know what that means, when a salt diapier or a salt wall bursts up through a sedimentary package, as far as I understand, some of the sediments that are on the flanks of that diapier can be tilted almost to near vertical orientations. And if in a perfect scenario there's salt withdrawal on one side and salt emplacement up the other, in other words, one of diapier emerging, another one receding, it could flip it back over in a small area with a salt weld in between, which could later be exploited during the Lufillian orogeny and squeezed over top and folded over in the configuration that Alpha's shown. I'm sure there's many other ways that this could possibly be thought of, but it seems like they all have to involve some component of both extension and compression. But maybe someone else has some other ideas for it. And that's all we wanted to show you. We thought this was very strange and certainly didn't expect to see this when we started looking at the data. And we're excited by it, and hope that our discussions this week can help us learn from you how this might be the case, and if you know of any other places in the Copper Belt that we could look for some models to employ here. Thank you very much.